Hello everyone. Thank you for tuning in to the second part of our Healthy Hakko, the Fermented Culinary Arts of Japan series. Today we're sitting down with two experts on the science behind Japan's iconic fermented drink, sake, and the microbe that started it all, koji. First, please allow me to introduce Dr. Stephen Lyman, author of the 2020 James Beard Award-nominated book, The Complete Guide to Japanese Drinks. Dr. Lyman was the first shochu and awamori ambassador officially recognized by the Japanese government, and he has spent time working in both sake breweries and shochu distilleries. One of the leading American experts on shochu, he has visited more than 90 shochu distilleries and sampled approximately 3,000 brands. Today, Dr. Lyman is joining us all the way from Fukuoka, Japan. Dr. Lyman is also a clinical epidemiologist and affiliated with Weill Cornell in New York City. But for the purpose of today's discussion, we'll try to limit our questions for him purely to sake. We're also joined today by Dr. Victoria Lee, Assistant Professor of History at Ohio University. Dr. Lee received her PhD and MA in History from Princeton University and her Master of Science in History of Science from the University of London. A Toronto native, Dr. Lee left our city quite a while ago and hasn't really stopped moving. She was a Japan Foundation Fellow in Tokyo from 2010 to 2011, after which time she carried out research as a postdoctoral fellow at the Max Planck Institute for the History of Science in Berlin. She has taught at Rutgers University in New Jersey, and today she is zooming in from Paris, France, where she is currently a fellow at the Paris Institute for Advanced Study. Dr. Lee's primary field of research is Japan's engagement with microbes in science, industry, and environmental management. Her upcoming book, titled The Arts of the Microbial World, Fermentation Science in 20th Century Japan, will be published by University of Chicago Press in fall of 2021. Well, I will now sit back and let our experts tell us all about this tiny yet mighty microorganism, koji. And later, I will return, hopefully a little smarter, and we'll just have a sit-down chat about sake, koji, and much more.
Great, thank you very much for that kind introduction. I'm very happy to be here today at the Japan Foundation of Toronto, albeit remotely. I will start sharing my screen. So, as I was kindly introduced, I'm Stephen Lyman, the author of The Complete Guide to Japanese Drinks, which explores all of the koji alcohol traditions of Japan. And you can find me online if you so desire. I'm happy to answer questions. So I think it's not too much to say that the history of Japan is a history of alcohol in a lot of ways. The islands have been occupied by humans for about 17,000 years. And the early settlers are believed to have come by boat, but that's not really the purpose of today's talk. But the first evidence of alcohol production in Japan actually was around 3000 BC, so about 5,000 years ago, in Sanae Murayama in Aomori, Japan, where there is evidence of fruit fermentations in which fruits were converted to alcohols. And that's one of the earliest examples of alcohol production in Asia anyway, or at least in Japan. However, we're not here today to talk about fruit ferments either. We're here to talk about the use of other microorganisms in alcohol production. And so there was a big leap forward again in around 1000 BC, so about 3000 years ago. And that's when rice cultivation began in Japan. This was imported from the mainland in Asia. And shortly thereafter, kuchi kamizake became a thing. Now this is mouth-chewed sake. This is where you chew on some steamed rice and you spit it out into a pot, and the enzymes from your saliva help break down the starches in the rice, and the yeasts, ambient yeasts, convert those starches. The enzymes convert the starches to sugars, and then the yeasts, natural yeasts, start to convert those to alcohol. And after about a week, you might have a low-proof beer, rice beer of sorts, through this process. And it was demonstrated in the popular anime Your Name a few years ago, which is where these stills are from. So that started around 3,000 years ago. Fortunately, around 550 AD or so, we're not exactly sure when, there was another great leap forward. And this one is quite a bit more sanitary than mouth-chewed sake, which the mouth-chewed sake was actually shared by villagers. So the old women and the children would chew the rice and spit it all day while the people worked the field or did the hunting or whatever, and they'd come back and drink the kuchikame sake. So fortunately, we have advanced since that time. And in 550 AD, Chinese fermentation methods arrived in Japan. This is where koji was first introduced to Japan through Chinese yeast balls, we believe. And these yeast balls have been evaluated biochemically, and I'm sure Dr. Lee could speak to this as well, but these yeast balls contain dozens of organisms, molds, yeast, and bacteria. And these are used in fermentation in other parts of Asia to this day, but the Japanese took it in a different direction, and they ended up isolating three organisms, Aspergillus mold, Saccharomyces yeast, and Lactobacillus bacteria. And those are really the foundations of traditional sake production. So Aspergillus oryzae is the mold. This is koji, actually. This breaks starches into sugars. So it does the process of the same action as the kuchikame sake, where you chew the rice and the enzymes in your saliva break down the starches. This mold does that for you. And then Saccharomyces cerevisiae, which I'm probably butchering that, but that's the yeast. And this is actually the yeast used to make all sorts of alcohols. This converts sugars to alcohol. And then Lactobacillus is a bacteria that creates natural lactic acid, which protects the sake fermentation from other organisms. And that's the traditional way that sake was produced. So Aspergillus mold is koji, as I mentioned. And this is an example of actually black koji. There are several different strains. Now, koji really is an incredible organism, and it really is the foundation. It's the backbone of Japanese fermentation. It's actually the national mold of Japan. Japan is so serious about their molds that they've identified a national mold. This is used in sake production, soy sauce, mirin, miso, pickling, shochu, as well as awamori. And it's actually also can be used as a meat tenderizer or as a digestive aid. So there's all sorts of uses for koji in Japanese fermentation and Japanese life. So how does koji work? So koji mold is grown on steamed rice or another starch base, and it creates amylase and protease, as well as other things. And the amylase actually breaks down complex carbohydrates or starches, and the protease can break down proteins. And through this process, essentially koji eats starch, and the byproducts are heat and sugar. And the yeast needs access to simple sugars in order to convert it to alcohol. So this is the process by which sake is made, because there's no ready sugar in rice. You have complex carbohydrates. You have very little ready sugar in rice. You need to extract that sugar from the complex carbohydrates from the starches, and koji does that job. So getting back to our timeline, we're not going to spend too much more time on this, but just a little bit longer. So that's when Chinese fermentation methods were introduced, which introduced koji. But a more romantic story, which I've actually heard told, is that a wise old farmer found koji mold growing on rice in his field, and this is where koji originally came from. I think the Chinese importation is probably more accurate. So in 1550 AD, a wise old farmer discovered koji, and we were off to the races by this telling. And so this introduces really Japan's first truly indigenous alcohol tradition. There's the styles of rice brew that are made in other parts of Asia are not like Japanese sake, because those three organisms are not isolated as they are in Japan. And this really took hold in the 700s in Nara, which was the capital of Japan prior to Kyoto. And these essentially what are even now considered modern sake methods were developed by Buddhist monks in that city as early as the 700s. This is where rice polishing was developed for sake production, where koji was actually cultivated by koji makers. This is where they learned how to make lactic acid and then making a yeast starter and making the main mash. These are all parts of the modern process of making traditional sake. And then finally pressing sake, rather than drinking the cloudy fermentation, which is similar to today's nigori sake or cloudy sake. The pressed sake is the clear sake that we're used to drinking today. And that was, the pressing started as early as the 700s or 800s AD. And so this is sake. This is the beverage of Japan. The ingredients are simply water, rice, yeast, koji, and then lactic acid or lactic acid bacteria. So modern sake is often made with commercial lactic acid. So they don't try to incorporate the lactic acid bacteria into the process anymore, but there are still traditional styles that use that bacteria. As far as production, it's fermented and then pressed, and then it's ready to drink, and it's made nationwide throughout Japan. Other names in Japan are Nihonshu and Seishu. Seishu is the official name. Nihonshu means Japanese alcohol. And that's really when Japanese alcohol traditions began, was around 700, 750 AD. But that's not where it stopped. There was actually a new technology introduced a little bit before 1500 AD. And that actually happened in the Ryukyu Kingdom. The Ryukyu Kingdom was actually an independent country south of Japan. And it's now actually modern day Okinawa. And you can see on the map, Ryukyu was actually a key trading post for all of Asia. They traded with China, with Korea, with Japan, with what was Siam, is now Thailand. They traded all throughout Asia. And so they became quite influential. And through all of this trading, distillation technology arrived in the Ryukyus. And these were traditional pot stills, much like you can still find in rural parts of Southeast Asia, as well as in parts of Mexico with traditional mezcal production. These stills are still being used. Now, what makes awamori, or the Okinawan style of alcohol, unique is they use Aspergillus awamori, or Aspergillus luchensis, which is black koji. This is an ancient, very robust mold, different from Aspergillus oryzae, which is the yellow koji that's used in sake production. And Okinawan awamori was born out of this. Now, the difference between awamori and sake is that awamori is distilled. It's still made from rice, yeast, koji, water. However, there is no lactic acid bacteria because black koji creates a lot of natural citric acid, which can protect the fermentation from corruption by other organisms. And then awamori is distilled. And as a distilled beverage, it's a spirit, it's higher alcohol, it's clear. And obviously being higher alcohol, it's more robust, but because it's been distilled, there's no residual sugar, where sake has residual sugar, which is part of what gives it its sweetness. So around a little bit before 1500 AD, we have a Ryukyu awamori. The reason we consider this a Japanese alcohol is because the Ryukyu, or modern day Okinawa, is now part of Japan. So when did distillation come to Japan proper? It wasn't that much later, and this drawing may give you a hint as to why. The wave dominates the picture, but actually you see those fishing boats. And there was fishermen all throughout those waters surrounding Japan and Okinawa. And one of the most common theories as to how distillation arrived in Japan is actually Tsushima Island. So you can see it on this feudal map of Japan. There's Tsushima labeled. This is a map of Korea from the same era, and you can see Tsushima Island labeled. So Tsushima actually was a trading hub for fishermen. And we believe that distillation technology was traded between Korean and Japanese fishermen at Tsushima at some point around 1500 or maybe a little bit earlier. So that's when distillation arrives in Japan, and that's actually when shochu arrives in Japan. So Japanese shochu, again, is a little bit different than awamori and sake. Again, it's made with rice, water, yeast, and koji, but with shochu, you can also make it from other fermentable ingredients. It is also fermented and then distilled, so it's higher alcohol than sake. It's very similar to awamori. And about 90% of it is still produced in Kyushu, in the Kyushu region of Japan, which is down south, where it's generally too warm and hot and humid to make sake reliably. Now, another nuance between shochu and awamori and sake is the koji that's used. So yellow koji is used in 99.9% of sake production. Black koji is the only koji permitted for awamori production. And white koji, which is actually a mutation of black koji, is currently used most often in shochu, although it's not much more than 50% of shochu is white koji, and there's quite a bit of black koji and a little bit of yellow koji also used in shochu production. A little bit about how you make your koji for alcohol production. You're starting with rice typically as your base. You can grow koji on barley and on buckwheat or soba and other base ingredients, but typically it's made with rice. So first you have to wash your rice. It's polished rice, and you wash it to get off the residual dust, which would have proteins in it that you don't want in your fermentation. You then steam the rice. Then that steamed rice needs to be cooled down to a temperature at which the koji can survive. If it's too hot, the koji is not going to be happy. And then the koji is actually spread onto the rice, koji spores. This is actually white koji that has gone to spore. And if you look closely in the bowl, you can actually see grains of rice that have koji bloom on it. A more typical style for sake production is actually to use a sifter. So only the koji mold itself, the little spores itself end up on the rice, rather than those molded rice grains that you saw in the previous picture. And then you need to cool down that rice again. And this is typically done in these koji rooms, at least in a traditional style. These are cedar-lined rooms. They're very hot and humid because koji wants a hot and humid environment. But koji creates heat as it's converting starches to sugars. And you want to keep it cooler below a certain temperature so that the koji can remain active and continue the process. And so that's what they're doing here. This is actually barley koji, which they're cooling down at a distillery in Oita. And then usually on the second day after the koji spores have been inoculated on the rice is separated into these wooden boxes to more easily maintain temperature throughout the koji making process, which usually lasts about 48 hours or so. When the koji is removed from the koji room, it's inspected by the master brewer or distiller. This is actually, these photos are all from shochu distilleries where I have more experience. This is a master brewer distiller inspecting his white koji. You can see the nice white bloom on the rice. This is after 2 days. You can see the koji mold growing on the rice spores. And a key point to both sake, well, all three, to sake, awamori, and shochu production is multiple parallel fermentation. In this tradition, you have both the koji rice, the koji itself, and the yeast in the fermentation working at the same time. So at the same time that the koji is converting starches to sugars, the yeast is converting those sugars to alcohol. And that's unique to these Japanese alcohol traditions. In Western traditions, in beer production or whiskey production, where we're extracting sugars from starch using the malting process, first you malt, then you ferment. And in these alcohol traditions in Japan, the koji process, the saccharification of the rice, is happening at the same time as the yeast is converting those sugars to alcohol. And you actually do a lot of stirring here. And what you're doing when you stir these pots, I apologize for jumping forward like that. In stirring these pots, you're aerating them. So you're again maintaining temperature. You're keeping it cool. But koji is an aerobic organism. It needs oxygen to keep active. And yeast is an anaerobic organism. It does not want oxygen. So when you aerate like this, you're helping the koji to breathe. You're oxygenating the koji, and you're agitating the yeast. And the reason you want to do that is when you agitate yeast, it gives off aromas. And those aromas are actually favorable aromas, things that we want in our sake or in our shochu or in our awamori. So you spend a lot of time during the fermentation process stirring these pots. Typically, a shochu or awamori fermentation is going to last around 2 to 3 weeks, where a sake fermentation can last up to about 45 days or even longer for cold temperature fermentations. For shochu and awamori production, after fermentation, they go into these traditional single pot stills, and they're only distilled once, and that's where you end up with your final spirit. But in talking about koji and alcohol, I do want to tell one other story, and that's the story of the Japanese chemist Chokichi Takamine. He was born into a sake-making family, so he was around koji from a young age, graduated from Tokyo University, and actually made his several fortunes using koji. And he actually moved to Chicago in 1890 And that's when he was introduced to the Illinois Whiskey Trust in 1891. And the Takamine process was licensed to the Illinois Whiskey Trust to make whiskey. The Takamine process was actually a koji process to replace malting in whiskey production. Because it turns out that koji is better at malting than malting. Koji is more efficient at extracting starches from barley, extracting sugars from barley than malting is. So you end up with a more efficient fermentation. You end up with more yield of whiskey per batch of barley. However, just a few days after that article appeared saying whiskey was going to become cheaper, the distillery warehouse where they were conducting the experiments was burned down in a distillery fire under suspicious circumstances. The maltsters might not have been happy about being replaced by koji. However, about 3 years later, the Takamine process did start at the Manhattan Distillery in Peoria, Illinois. Unfortunately, only 3 months later, the Manhattan Distillery was shuttered because the Illinois Whiskey Trust had gone out of business, and this was the era of trust breaking in the United States. So the company never restarted, and the koji whiskey was lost to history. However, Takamine would carry on. He isolated adrenaline as a chemist in New York City, and he donated the cherry blossom trees to Washington, D.C., which you're ever fortunate enough to be in D.C. at that time of year. It's really, really beautiful. So thank you very much for your attention. Again, I'm Stephen Lyman, and be happy to answer any questions you have through social media. And I'll turn over back to our hosts.
Thank you. Thank you, Dr. Lyman. That was fascinating. I learned a lot. I learned a lot.
Thank you.
I have quite a few questions for you, but I'll hold off. And now we will turn the camera to Dr. Lee.
Thank you so much for inviting me to speak at the Japan Foundation Toronto. I'm really delighted to be here. And I'm going to start sharing my screen. I'm going to start with microbes. I merely borrowed the power of microbes. This is what Japanese fermentation scientist Omura Satoshi said when he won the Nobel Prize in Medicine in 2015 for his work on the antiparasitic drug ivermectin. What did he mean by the power of microbes? And what did he mean by borrowing it? This takes us at the beginning of our story to koji. Today, as we've just heard from Stephen Lyman, koji has been declared the national microbe of Japan by the Brewing Society of Japan, as you can see here. And we've just heard that koji is mold grown on steamed rice, that koji making is the first step in traditional Japanese brewing to make products like sake or soy sauce or miso. And this mold, this rice mold, produces enzymes that when you apply them to soybean or rice, it breaks down proteins into amino acids or breaks down starches into sugars. In the case of sake brewing, yeasts then enter and convert the sugars into alcohol. Koji is the national microbe because, as one scientist has put it, whether Eastern or Western, whether old or new, where human culture flourishes, one finds the technological operations and skills of fermentation. Yet, only in Asia, molds are used to turn starch into sugar before using yeast to ferment. And these molds create the special properties of the wine of each brewing region. Moreover, only in Japanese traditions is koji mold aspergillus used to brew alcoholic drinks. Other Asian traditions use predominantly molds other than koji to make alcohol. So in the declaration of the Scientific Conference of the Brewing Society of Japan, the national microbes are, as are listed here, Aspergillus oryzae, Aspergillus soyae, Aspergillus luchuensis. The first is used to make sake, the second is used to make soy sauce. Both of these are yellow koji microbes because their spores are yellowy green in color. In the language of brewers' vernacular, kikoji kin. And the third has spores that are black in color. It's used to make awamori, and in brewers' vernacular, that would be kuro koji kin. The white mutants that Stephen Lyman mentioned in his talk are also included in that category. Note especially the word kin here for microbe. In English, when we say microbe, we usually think of deadly bacteria or germs. In Japanese, kin doesn't primarily mean germs, it means fungus. In the modern era, Japanese society had two ways of thinking about microbes. The first is the one more familiar to us. They're enemies. We need to use vaccines and quarantines to eradicate them. The second is thinking about microbes as living workers that make products to help society. And it's this second way, microbes as living workers, that's really distinctive to modern Japan. And Japanese science owes this to koji. The word kin reflects both ways of thinking about microbes. And in fact, the connotation of fungus is a little stronger than bacteria. So this way of thinking about microbes is a hidden way in which craft traditions from pre-modern Japan crept into modern science and stayed there, mostly in an invisible way, but leading to powerful innovations today. So I'm going to talk about how the story of the craft of koji got into Japanese microbial biology and shaped it in such a prominent way, especially through the technique of pure culture. Before the late 19th century, brewers did not have the concept of microbe at all, but they did have ways of understanding and handling molds as part of essential stages in brewing. In 1901, the professor Kozai Yoshinao, who was an agricultural chemist at Tokyo Imperial University, stood before the Tokyo Chemical Society, which was the main meeting place for chemical industrialists like sake brewers and scientists to exchange information. And he was explaining in this lecture to brewers the microbiology behind these processes. He started by describing the basic nature of the process first. One needed koji, the most essential material in the brewing of sake. And it was made by steaming rice, then adding tanakoji, which are koji spores, and we'll come back to that in a moment, dampening it, and then allowing the growth of a kind of mold. And when the koji was ready, one made moto, the material needed to ferment sake, by mixing koji with steamed rice and water and then making it ferment through manual art. This took about 18 days, and it was the most difficult part of the toji, that's the head brewer, his job. The toji was part of a seasonal labor force who would come to the brewery to brew in the winter months. Kozai explained these materials to the audience in the terms of microbiology and chemistry. Koji changed starch into sugar by the power of mold, and then moto changed sugar into alcohol and therefore contained abundant amounts of yeast. And here he called it isto, signifying a foreign term. With just koji and moto, he said one could produce sake from water and steamed rice. Kozai explained that because the koji spores and the moto, they weren't pure, but already mixed with various kinds of bacteria and mold. The buds of disease were already in the raw materials, and it was natural for the sake to spoil. The various mold and bacterial germs mixed in with the liquid would continue to provoke constant transformation in the liquid even after refining. And so during storage, there was a particular danger of spoilage. And this is why brewers had to be careful, and from time to time they would perform hiire, which is putting in fire, a heating process. But Kozai thought that wasn't enough. To improve sake brewing, it was necessary to remove every kind of harmful microbe. And he thought that you do this by using pure cultures. He encouraged brewers to stop making moto and instead to use pure cultures of yeast. And he emphasized yeast here and not koji because pure yeast culture was a model lifted directly from a method for beer that Kozai would have encountered closely during his study in Berlin, from which he had just returned when he gave this lecture. By this time, we're still in 1901, there had already been 2 decades of movements to improve the sake brewing industry using the application of scientific principles. Everyone was invested in this because sake brewing was by far the largest manufacturing sector in Japan in terms of production values in this period. And the Meiji state was also invested because sake brewing provided them with their biggest source of tax revenue. even higher than the land tax. And we can see how microbes appeared to brewers in the 1900s in the preeminent trade magazine of the time, Jokai, or Brewing Ocean. This is a Q&A column on the top left here, where a reader has asked, who are the great enemies of sake brewing, bacteria? And the scientist answering has illustrated the common bacteria that cause sake spoilage, how they look under a microscope. Another lecture published in the magazine explained the importance of hygiene in brewing. Some still believe that sake was the work of the gods, he said. But disinfection by new chemical means was essential, and the people who worked in the brewing houses must also keep clean clothes and clean bodies as if they were in a sacred place. It was no coincidence that good sake was produced in places that adhered to such customs. The Meiji state established a national brewing experiment station in Tokyo in 1904 under the tax department of the Ministry of Finance. And the Brewing Society of Japan, this is the society that would 100 years later declare koji to be the national microbe. The Brewing Society of Japan was linked to the brewing experiment station, and they worked with university scientists to promote yeast pure culture in sake brewing. But actually, the majority of brewers in the celebrated Nada district, for example, they were not using yeast pure cultures until the late 1960s. And it's a little bit to do with how the role of lactic acid bacteria was not clearly understood at that time. So the management of yeast pure culture was not fully understood. But koji pure culture, on the other hand, followed a very, very different story from yeast pure culture. And this is partly because the industry, of the way the brewing industry was structured. The making of koji, it had already been a lucrative monopoly industry conducted by specialist koji makers since the 13th century. And by around 1900, when these movements for pure culture were going on, the koji spore industry had become a distinct sector from the koji industry. Some of the spore makers traced lineages to those medieval koji making monopolies. The dried koji spore preparations were used to seed the making of koji, and these spores were called moyashi or tanakoji, and they would be sold either to koji makers or directly to sake or soy sauce brewers who made their own koji. Why would brewers or koji makers turn to this small-scale, secretive, highly specialist sector of tanakoji makers? Because the original spore starter was quite difficult to generate. So in theory, if you have a sake or soy sauce company and they build a koji room, it's possible just to make koji starter by taking an open koji box, putting in, if you want microbes that are suitable for soy sauce, you put in steamed soybean and ground wheat, or if you want microbes for sake, you put in steamed rice. And then you leave that open koji box on the shelf of the koji room and you wait for the mold to enter from the air. In a long-standing koji room, plenty of good koji microbes should be there and just be floating in the air and would settle in your box. But how can people actually get to that point? Where do good koji microbes come from? And moreover, how can you maintain good koji after finding it? At that point, it was quite common practice to shake off the spores of the koji if you have a good brew, dry those spores, and then use them as seeds in the next round of koji making. But with successive culturing like this, any good koji will become old and produce fewer spores and become contaminated by other molds and other things. Tanakoji makers, on the other hand, had established practices for distinguishing between cultures of koji and for propagating good koji microbes. By inspecting the color of the spores, which should be yellow or yellow-green, as you can see here, one could tell what kind of mold the koji consisted of, as well as how old the koji was, because the spores tended to darken to brown with successive culturing and with time. From the smell, one can tell how dry the spores were and how they were produced. This varied widely between makers, with especially well-known differences between makers in Kyoto and Osaka. And these differences come from various things. The source of the ash used, more on the ash in a minute, how they stack the koji boxes during culturing, the way in which they dry the spores and how much they dry them, If the Tanakoji maker put the spores in his mouth, he could make similar distinctions through their taste and hardness. And finally, the maker could actually make koji, growing the mold on steamed rice, and see how smoothly that went. And then ask breweries to try out the Tanakoji and see how the sake, soy sauce, or miso tasted. And by these means, the moyashi maker could select the best spores. Makers had also, since the late 13th century, attempted to store and maintain and propagate these mold cultures as purely as possible by adding special ash. Unlike yeast, the pure culture of koji was taken up by industry rapidly. Kono Kenji, formerly the head of Akita Kono Shoten, the moyashi maker, he described to me his childhood memory of watching a technician making genkin, or generating the original starter microbes, using Meiji-era methods for doing this. Starting with a mass of spores floating in water, he used a syringe to deposit a droplet of the spore mixture into a container of pure water, repeating until he had a very dilute mixture. Then he would draw a mark on the cover glass and look at the sterile colored liquid through the microscope to see whether there was only a single spore on the dish. If there was, he sterilized a piece of filter paper by splashing alcohol in it and used it to suck up the spore. He expanded the single spore into a colony by culturing it on rice grains, in other words, making koji in flasks. Then he subjected the pure colony to testing, investigating properties such as the formation of proteases, amylases, acid-resistant amylases, and so on. And then taking the spores from that colony, he repeated the entire process, perhaps hundreds of times. In this manner, by thoroughly investigating weak and strong microbes using the single spore method, only the microbes with the very best qualities would be propagated and made into starter. Droplet by droplet, taking spores wrapped in single droplets, one could cultivate them and bring up their descendants. It is likely that Tanakoji companies who cultured koji microbes pure were in the minority in the early 20th century. In the post-World War II period, however, the number of moyashi companies shrank compared with the 100 or so that had existed at the beginning of the 20th century. By the end of the 20th century, there were only about 15 Tanakoji companies, of which 6 distributed nationally. Though the companies were all small scale with fewer than 50 employees each, the concentration of the industry implies the level of technology that was needed to stay competitive. And other companies simply would not know how to stabilize the same microbe even if they acquired it, or have the resources to maintain microbial collections, which are living and so need to be constantly recultured. This technique of pure culture, which enabled a single microbial strain to be isolated, physiologically characterized, classified, and preserved over time, was fundamental to science as well, meaning, among other things, that microbes could be classified and studied as species. This exchange between scientists and brewers, it wasn't just in the physical microbes, it was also in ways of thinking about and classifying microbes. Scientists were gathering microbes from breweries across the country and doing work on studying them and classifying them. For example, they found that for sake, a whole variety of strains might exist even in one sake, but the biggest differences are really between industries. So the fungi used in the sake industry form more sugars, for example, whereas the fungi used in the soy sauce industry made enzymes that formed more amino acids, which are chemicals more associated with flavor. And it was clear that the configurations of the enzymes that are made by different koji microbes are related to how brewers had selectively bred particular kinds of microbes in different breweries. It's in this way that scientists came to see koji as being part of a whole diversity of useful fermentation microbes produced in Asia. For example, there's, as you can see here, Aspergillus oryzae for Japanese sake, Wenti for the soy sauce of Java, Luchuensis for the awamori of the Ryukyu Islands, Batatai for the sweet potato liquor of Hachijo Island. But there's also Monascus purpureus for Taiwanese red koji liquor, and the so-called Chinese yeast or Chinese koji that consisted of various mucor and rhizopus varieties used in China and Southeast Asia. and which functioned just like Japanese tanakoji. This is how microbes, kin, became thought of more generally as living workers. In the end, what happened to fermentation science in those university departments of brewing and agricultural chemistry, which built the foundations of their discipline on collections of koji molds and yeasts? Those departments grew massively in size and range after World War II. They mostly changed their names to departments of bioscience and biotechnology now. But Japanese scientists through this time have relied on microbes to make products including vitamins, biofuels, antibiotics. Many new antibiotics were discovered by Japanese scientists, flavorings, including MSG, but also flavorings that sort of may be less familiar, like IMP or GMP. These are all fermented by bacteria. Statins, these are made by a fungus. They were discovered by Endo Akira in the 1970s for controlling cholesterol, and they're some of the best-selling drugs in pharmaceutical history. Ivermectin, for which, as I mentioned at the beginning, Omura Satoshi won the Nobel Prize in 2015. This here is the microbe mound, Kinzuka, at the Manchuin Temple in Kyoto. It was built in 1981 to commemorate the souls of microbes who had died in the service of humans. The scientist who provided the calligraphic inscription for it, Sakaguchi Kinichiro, he's also famous for his motto that every fermentation scientist in Japan knows: ask microbes and they will never betray you. Thanks.
Thank you, Dr. Lee, for that fascinating talk. I love that image at the end of the monument for microbes, for koji, and dedicating it to their sacrifice. Not something we think about when we are in a restaurant and drinking sake or shochu, but I love that image. Okay, so I have a lot of questions, mostly because unlike the two of you, I'm in no means an expert in this matter. So I'll just sort of ask what's on my mind, I guess, and these questions are not targeted to either of you in particular, but if you happen to know the answer, please feel free to jump in. So because Dr. Lee, your presentation is still fresh on my mind, I want to direct my first question to you, if possible. You mentioned that near the end of your presentation, a lot of bioscientists were going into these breweries to categorize microbes and naming them. There seems to be an interesting, I guess, connection between the scientific community and these very, very traditional crafts people. I was just wondering if there's a flow of the other way around, in which the scientific community is now giving back to this traditional craft, in which, I guess what I'm asking is, are sake breweries in Japan nowadays looking ahead into the future and using bioscience to change their technique or improve their technique in any way?
Actually, it's not just today, but there have been close links between breweries and academic scientists for over 100 years. You've had programs in departments like the brewing department of Osaka Higher Technical School, which later became the Faculty of Engineering at Osaka University, which trained brewing technicians from around the country. And that was already open in the first couple of decades of the 20th century. So you have had brewers' sons going to these technical schools to train, as well as national experiment stations around the country that it was their job to connect with brewers, to run training programs. But you also have a lot of brewers who are academically trained. And so this has been developing hand in hand, academic institutions in microbiology and also brewers' institutions for over a century. And even when the discipline started to diversify in academia and microbiology there moved a little bit away from direct studies on brewing, and even when the brewing industries started to mechanize and get bigger, so you weren't sort of talking about small scale breweries anymore on the whole after World War II, there were still very tight-knit relations between industry and universities. And industries actually, they would invest a lot in microbiological departments after World War II. You have very close links between different sectors of the fermentation industry. So breweries, chemical companies, drug companies, they're actually very closely linked. So you have what you would think of as food companies who are making penicillin, for example, in the mid 20th century and making antibiotics. And they would pull in scientists, academically trained scientists with PhDs into microbiological departments to do research. And that's how you come up with, that's how a soy sauce company, for example, came up with, Imasa Shoyu came up with a technology to ferment IMP and GMP, these nucleic acids, which produce a flavor, just like MSG, different kinds of umami flavor, for example.
Thank you. And Dr. Lyman, I know you've visited a lot of distilleries, shochu distilleries, and maybe sake breweries as well. So like down on the ground, I guess, are you seeing a lot of these brewers these days with advanced degrees or trying to implement new techniques, anything like that?
Well, a lot of the younger brewers and distillers have gone to these technical colleges or agricultural colleges to learn these techniques from academic departments, but also there is close collaboration both between these laboratories in developing either new yeasts or also sometimes when a shochu distillery, I see this more in the shochu world currently because I think there's a lot of experimentation going on. The distillery will collaborate with a scientist from a university to try to identify a way to capture a specific aroma profile that they're trying to achieve. And sometimes they'll even credit the scientist in their promotional materials. So these relationships are alive and well.
That's great. That's great to hear. And that's, I guess, key to advancing the next step of, well, something we benefit from as consumers. I'm just looking at my question that I've written down here. So what are some of the health implications of drinking sake? Obviously, because sugar is produced in the process and too much sugar is not great for our bodies, I guess there are some health implications of overindulging. And we should never overindulge in alcohol. But what are also some of the health benefits, perhaps, of drinking sake once in a while?
I guess I can take that one. I'd preface by saying that drinking alcohol is not a healthy behavior, but there are healthier options when it comes to drinking. And among fermented beverages, so when I say fermented, I mean not distilled. So that's our broad categories would be wine, beer, sake. Among those, sake has some purported health benefits relative to beer and wine. Although wine, as we know, red wine has heart healthy enzymes that which has sort of changed everybody's thinking about alcohol generally. I think because before that came out, alcohol was just bad. No alcohol, right, was best. But we've now learned that humans do have a long relationship with alcohol. Mm-hmm. I don't think it's going away. But in distillation, you're removing those sugars, as I mentioned during my talk. And so there's actually scientific medical research demonstrating that they randomized, it was a Japanese study in which they randomized subjects to eat the same meal 3 days in a row, the same dinner. And they were randomized. So one night they had water, one night they had beer, one night they had sake, and one night they had shochu. And in all three cases of alcohol, after their meal, they were monitored and their blood pressures lowered for all of them because alcohol calms you down, right? You relax. So the blood pressure lowered, the heart rate lowered. So that was the benefit of all of the alcohol compared to water. Water was the placebo. But in beer and sake, the blood sugar spiked. And in shochu, it did not. In fact, the blood sugar levels after consuming shochu were lower than with drinking water. And there's additional research that demonstrates that shochu has some properties that actually reduce the risk of blood clots, especially in sweet potato shochu. And so there are some benefits to drinking these, again, in moderation. Probably no alcohol is not necessarily great, and too much alcohol is not really great. So it's good to find a happy medium.
Right. Speaking of shochu, and I think I mentioned in my introduction of you that you're a shochu ambassador. Can you just tell us a little bit of how you got into shochu in the first place? Because outside of Japan, shochu is still not quite as popular or well known as sake.
That's right. It's really not. It's I discovered it in an izakaya in New York City, just by chance. So izakaya is a Japanese tavern or gastropub, I guess is a way to describe it. Casual place with food and drink, and I just happened to discover shochu and never heard of it. Was interested in it and got me excited. But to your point about it not really being known outside of Japan, it's sort of an accident of history because Japan closed shortly after distillation technology arrived. And by the time Japan reopened in the 1800s, other Western spirits traditions had become worldwide drinks, right? Scotch whiskey, American whiskey, even rum, which rum wasn't even developed until much later than these other spirits traditions, but it became world known before shochu. Even today, less than 1% of shochu is exported. But to give you an idea of the scale of shochu in Japan, there's more shochu produced in Japan than tequila in Mexico every year. But 70% of tequila is exported. Only 30% is consumed in Mexico. 99% plus of shochu is consumed in Japan.
Oh, wow.
So less than 1% exports even today.
Yeah, before I went to Japan, never heard of shochu, but it's quite popular there. If you go to any izakaya or bar, shochu is pretty much a staple drink.
That's right. It outsells sake. It's outsold sake every year since, I believe, 2006.
Well, thank you for your hard work on bringing shochu to the United States, introducing it to the populace there. I don't know about Fukuoka or Paris, but right now in Toronto, it's very cold. And on cold days like this, I wish I could have, a little tokuri of atsukan, which is warmed up sake. Now, you don't really warm up beer. I think that's, maybe some people do, but I would never warm up beer. But warmed up sake is quite delicious. And just from what little I know of sake, there's supposedly certain brands or certain types of sake that taste better when it's warm compared to when it's chilled. Would you happen to know whether that's just something sake sellers push or say, or if there's something in the process of making sake that they specifically narrowed down for that taste of warmed up sake?
Great question. Hot sake is definitely a thing in Japan, and it has been for a long time. The reason you warm up an alcohol like sake is to release aromas. Oh, it's from a warmer drink. It smells better and it tastes stronger. Cold suppresses our sense of taste, right? The reason we drink ice cold industrial lager beer, I won't necessarily name brands, but the reason we drink those ice cold is because they don't taste very good once they warm up. The reason you can drink those rich, heavy Belgian beers at room temperature or thereabouts is because they actually taste good, right? So with sake, by warming up a really fine sake, you're enhancing your experience. You're getting more out of it than you would if you're drinking at room temperature or chilled. So there's an anecdote in my book, actually, in which a sake maker was at an izakaya and he ordered his sake and he ordered atsukan, and the owner of the izakaya refused because this is when sake, like hot sake, was considered like not a good thing at that time, right? This is during one of the sake booms. So the sake maker ordered a bowl of stew and the cold sake, and he took the tokuri and he put it in the stew to warm his own sake. So warm sake is definitely a thing. As far as which sakes to use, I would say something that's more full-bodied, like a junmai or a honjozo sake. They tend to be richer in flavor generally. Those are going to express themselves better warm than like a ginjo or daiginjo. Those ginjo aromas that you get, which is just these fascinating fruity floral aromas, they don't quite work as well warm. They're really nice, a little bit cooler. And then there's also the entire spectrum of temperature. It's not just hot room temperature and cold. The Japanese have an entire language for about 5 or 10 degree increments, and this is in Celsius, of different ways of drinking sake. And if you drink the same sake all those different ways, you're going to get a different experience at all the different temperatures. So it's fun to experiment. And the other aspect of this is shochu and awamori can also be consumed warm. But usually what you're doing is you're diluting it with hot water. So you're taking room temperature spirit and you're diluting it with hot water, and that's called oyuwari, or cut with hot water. And usually you would start with your hot water first, and then you would pour the shochu or awamori on top of it. Usually at about a 50-50 ratio. And that opens up it brings out the aromas of the spirits really nicely as well.
Oh, okay. I didn't know any of that. I feel like such a brute just putting my tokuri in the microwave for 40 seconds. Okay, going back to the microbes, it seems like there's such a dedicated process of categorizing them and preserving different strains of them. And both of you touched upon the dangers of contamination. So I was wondering whether either or both of you could speak to how rare are some of these strains of microbes that are being used in fermentation processes, and if they become contaminated, are they lost to us, or is it a relatively simple process to reproduce them again?
There has been quite an extensive history of gathering microbes from breweries in Japan and preserving them in a lot of different places. I mean, the breweries have their own collections, companies have their own collections, but also these universities and brewing experiment stations, and there are dedicated national microbial collections as well. They all have gathered a lot of microbes from different breweries. And of course, it's not comprehensive, but it is very, very extensive work. And those collections, interestingly, in Japan, you can see the focus on good microbes over pathogenic, disease-causing ones, because microbial collections in, for example, Britain or the US, the big collections there tend to focus on bacteria that cause disease, whereas in Japan, the big national microbial collections, they have a lot of molds and yeasts in them, much more than bacteria historically. But if a brewery loses their special strains of microbe, are they necessarily preserved in one of these university or national collections or not? That's a little harder to say. When brewers were I have a couple of stories. One is that when brewers were introducing yeast pure culture into breweries after the Second World War, some scientists were actually worried that the traditional strains would be lost, and that triggered a wave of gathering things. But there's also a sadder story from World War II that's linked to awamori microbes on the Ryukyu Islands or Okinawa, which were largely lost during the fighting in World War II. So today, the fact is that the National Brewing Experiment Station in Tokyo also lost their collection during the war. They were burned down. But the University of Tokyo sent their collections away to Morioka to take sort of refuge during the war. So they actually preserved those. So now you have awamori brewers from Okinawa who are going to the University of Tokyo to see if they can recover some of those pre-World War II awamori microbes.
Oh, wow. Yes, I'm still digesting that. That seems very dedicated, I think. Is there a push for more recognition of microbes in your field of research, Dr. Lee? Because I know you mentioned conservation at one point in...
There's definitely, when Omura Satoshi got the Nobel Prize in Medicine, he did mention that he would be funding funding institutes that would support this kind of applied and industrial microbiology more. Because while it has been a big field, especially in Japan, it's under-recognized compared to other areas of the sciences so far. I think this is largely changing in the 21st century because of this recognition that microbes are so diverse, and they house, they're sort of such a repository of genes and with a capacity for doing things that we don't know about, like CRISPR technology, for example. So Japan was sort of earlier perhaps to recognize that than some other scientific traditions, but that's sort of changing in the 21st century, I think. Yeah, there is more of a push to look at microbes as this largely unknown world that you can that can give you anything if you only know how to ask for it.
Well, thank you, especially for answering my question so well when I'm having a little trouble articulating. It's just such an interesting new field that I guess even though microbes are everywhere around us, I don't think the typical person thinks about them that often.
Because we can't see them.
Yes, exactly. So I'm glad we had this opportunity to really look at this koji in particular today. We'll be wrapping up soon, but I was wondering in the meantime, I know the two of you have spoken prior to today about your own research and understandings of koji and microbes, but I was wondering after seeing each other's presentation, did you have any comments or questions for each other that are new?
I have a question, which is, how do brewers think about this long history that you presented us with? And does it help them in their work? Do they draw inspiration from it?
I think they do. There's definitely a sense of history and of responsibility in carrying on the traditions. And I know for a lot of the younger generation now, they go away, they get educated. And these, most of these breweries and distilleries are in rural communities. These are not in big cities generally. There are some in big cities, but most of them are in smaller towns and in villages. And so you go away to college, we've all done it. You go away to university, you see the world, you experience the big city life, and then suddenly you're called home to, the little town of 500 people, and you've got to make that decision. And when they do, they become really dedicated craftsmen. And I think part of it is that historical perspective that they are one in a generation. And when you talk to these people, they often will identify themselves as, I'm the 5th generation, I'm the 6th generation, I'm the 12th generation, and they, in some ways, felt that they didn't have a choice. And yet once they made the decision, to take over the work, then they've made it their life's work. And I think there's a lot to admire in that, especially in modern society, So it's been really interesting to talk to brewers and distillers about that, but they almost can't imagine another way of life, right? This is what they do. This is what they're intended to do. And they're very proud. And I think as somebody who's, I come from an academic background. I lived in New York City. I've, worked in universities, and I understand sort of that, in a sense, it takes a lot of courage, I guess, to get out of the rat race, right? In some ways. But the other aspect of it is, I've spent my career as somebody who was paid for thinking and making this, doing research and scientific experiments and that sort of thing, to go into one of these breweries or distilleries and work with my hands to make something, aided by, koji and yeast and the other organisms that are in the distilleries, the house yeast and things. You get a real sense of making something, and you get a real sense about how we're all connected. And when I say we, I mean all of these organisms, right? The microbes and humans. And the Toji that I've worked with most often, his favorite expression is koji is honest. And what he means by that is that if you slack off in your koji propagation or in your temperature control, in your aerating those pots or any step of the process, you will not get a good result. because koji is going to do what koji does. And unless you make it happy and let it do what it does as well as you can make it do it, you're not going to end up with a high quality drink at the end. And, but I think one of my points, I think I had several trains of thought going at the same time, but one of my points was that, you know, there's a sense of pride in the craftsmanship. And I think that's what drives these people when they decide to come home from Tokyo or Osaka to work in these small breweries or distilleries, is, you know, the genuine joy you see on their face when they're introducing their drink to a customer and they see the customer genuinely enjoy it. You know, it's a really nice feeling. So I think that's part of what drives them as well.
I've heard that there's an old motto from the Tanakoji industry, like onko shishin, sort of cherish the old while find wisdom in the old while sort of embracing the new. And yeah, it seems to, because they're also using, some of these industries, they're also using electron microscopes, you know, they're using mutation techniques to find new microbes. And so it's sort of a combination of this long history of craftsmanship with these technical innovations, which I find fascinating.
Yeah. Something that caught my eye on your presentation, which I had no idea about, but you were saying the sweet potato liquor made in the Tokyo Islands. Is that the Tokyo Island shochu, the sweet potato shochu that's made in that region?
I think so. There's just such a diversity of microbial heritage, and when you study them as microbial species and start collecting them, that comes out as well in the variety of the strains that you get.
But
like you were saying.
I'm sorry, is that actually a different kind of koji? Because I think it had a different name than what I had expected.
I think it's a different kind of koji, which is sort of, it's how scientists found that different drink products that have a distinct identity from other drinks, they tend to be accompanied by distinct species identities as well. And there are lots of arguments that you can have over microbial classification. I mean, where do you draw the line exactly between one species and another? But there are real differences that correspond to different industries, and that give drinks and fermented products their distinct character, as you were saying about awamori as well, and how those microbes are very, very different from these yellow koji microbes that are used in most of the Japanese archipelago.
That's right. That, you know, I've had those island shochu before from those islands off the coast of Tokyo. When we say off the coast, we're talking about 1,000 kilometers out in the ocean. They're really, really far from Tokyo, even though they're still considered part of Tokyo as a municipality. And those shochu are wild. They're unlike any other shochu that I've had. And now I think I might begin to understand why. That it may be that it's actually a different strain of koji that's responsible.
What do you mean by wild? Sorry.
They, well, it's the only place that I've heard of where they actually do, at least on one of the islands, they do wild koji fermentation in addition to, because wild yeasts are common in spirits traditions. So, you know, there are natural wines which are made through just allowing the ambient yeasts to start the fermentation process, because grapes have ready sugar, right? So that's kind of easy. Mm-hmm. But with a grain alcohol like sake, like shochu, it takes a long time to get ambient yeasts activated. But some do it. There are distilleries I've been to, they'll use a little bit of commercial yeast, and then they'll just open up the windows and open up the tanks and just come on, join the party. Any of the yeasts that want to come into the fermentation can. But the only place I've ever heard of wild koji fermentation was in these islands, where they will actually take essentially palm fronds and lay them over steamed rice, and that begins the koji fermentation, because the koji is on the fronds of the plant. And it takes much longer to make, apparently, than using commercial koji. But that's fascinating. It's actually a different species of koji, potentially. That's something I had no idea. That's really interesting.
You
But
can argue about the differences between species a lot, and people did, because koji, I mean, you find them in these Japanese breweries, but generally it's not something that you find outside of Japanese breweries, historically at least. I mean, now that's changing. Because how you classify essentially depends on how many strains you have and what range of strains you have. You can really get into arguments when your collections are different. When you have Japanese scientists saying, oh, there are real differences between sake koji and soy sauce koji, and then you have scientists elsewhere saying, well, no, there aren't, because we don't have that range in our collections. So it really is different, and there are vernacular traditions of thinking about these things, scientific traditions of thinking about these things, and processes of disagreement internationally that need to get resolved. I think what really comes out of it is, well, one scientist told me that fermentation isn't a technology, it's history, it's culture. And you can really see this in the diversity of even just the microbial species. And you see the diversity as well within the Japanese archipelago and in Asia. And it's fascinating.
Okay, on that note, it is past midnight for Dr. Lyman. We've kept you up quite late. My apologies.
My pleasure.
Thank you both so much for joining us today and giving us your fascinating presentations and answering my silly questions. So this recording will go up online the weekend of, I believe, January 22nd. For the duration of 3 days, and it will be accompanied by a documentary film titled The Genealogy of Sake, quite appropriate to our talk, I think. I hope everyone will tune into the film that's going to be showing this weekend, as well as part 3 of our Healthy Hakko series, which will be up next weekend. That part will have, I believe, 2 talks by experts. I had a lot of fun chatting with both of you today. Thank you for joining us, and we'll just wave goodbye, I guess.
Yeah, thank you, both of you.
Yeah, thank you.
Thank you.
It's a lot of fun.